Okay, let's unpack this. We have all been there. It is late at night, you're deep in a coding session with an AI assistant, and everything is just clicking. You feel like a wizard.
The code is just
The
flowing.
code is flying, functions are compiling, you're just vibing.
That's the one, the famous vibes coding phase. It's a beautiful place to be until the vibes turn sour.
Exactly, until the vibe turns into, I don't know, a hallucinated library that hasn't been updated since 2018, or the AI confidently suggests a command that if you actually ran it would nuke your entire hard drive.
And that's the moment the magic spell breaks. You realize you're not a wizard. You're just a supervisor for a very fast, very confident, but occasionally chaotic intern.
That is the perfect setup for what we're covering today. We are doing a deep dive into a repository called Master Claude Code Hooks. And the promise here is, I mean, it's incredibly bold. It claims to be the bridge from that vibes coding era into something they're calling agentic engineering.
It's a massive shift in thinking. We're talking about taking the non-deterministic, the creative chaos of a large language model like Claude.
And wrapping it in what? Rules.
In deterministic, hard-coded control structures, exactly. Rules, boundaries.
Safety.
Safety. Think about it. Right now, most people just chat with Claude. They hope it follows instructions. This system, these hooks, use Python scripts to intercept everything. It sits between you and the AI, monitoring what goes in and what comes out. It's essentially a management layer.
I love that concept. But before we get into the specific hooks, and I saw some wild stuff in there about blocking air-arf and voice notifications, we have to talk about the architecture. Because the first thing you notice is this UV single-file scripts architecture.
We do. And that's not just a technical footnote. It's actually crucial to making this whole thing usable.
I saw UV, and I'll be honest, my mind went to ultraviolet light. But I assume we're talking about Python packages.
Yes. UV is a Python package installer and resolver, but it's incredibly fast. See, the problem with running Python scripts to control an AI is usually the setup.
Oh, the virtual environments, the requirements.txt file.
You spend more time managing the environment than the AI.
Right, nobody wants to debug their debugger, you just want it to work.
Exactly. UV solves this with single-file scripts. All these hooks, they live in a folder called .claude-hooks, and because of UV, each script just declares its own dependencies right at the top of the file. UV installs them instantly, in isolation, just for that one script.
So I can have one hook that uses a heavy library like pandas, and another one right next to it that uses a web scraper, and they don't fight.
Zero conflict and zero setup time. It keeps your main project clean. You're not polluting your own repository with all these tools that are just meant to manage Claude. It's a huge quality of life win before we even get to the cool stuff.
Okay, so the infrastructure is solid. Let's get into the meat of it. The hooks, the source material, break them down into this life cycle of 13 events, which seems like a lot. But let's start with the ones that let us be control freaks.
The control freak hooks, a fitting name. And the first line of defense here is a hook called UserPromptSubmit.
UserPromptSubmit. Sounds straightforward. It fires when I hit enter.
Correct. You type your prompt, you hit enter. And before that text leaves your computer to go to Anthropic servers, this Python script just grabs it.
Okay, but why interrupt me? If I typed it, I want Claude to read it.
Well, do you? Or do you want Claude to read an enhanced version of it? This hook is powerful for two things: context injection and security. Let's start with context. How often do you find yourself repeating the same instructions? Remember, we're using TypeScript, or don't use any types.
Every single session. It's like Groundhog Day. I have a text file I just copy-paste from.
With UserPromptSubmit, you can script it so the system checks your project configuration and automatically attends those rules to every message. You don't type them, you don't even see them, but Claude sees them every time.
That's useful. It's like whispering the context in Claude's ear before I even speak.
It goes deeper. You can inject dynamic context. Imagine a script that runs git status or grabs the last 5 lines of your error log and just appends them. So when you just type fix this, Claude already has the error log and the file changes. You didn't have to do a thing.
That is slick.
Yeah.
But you mentioned security. I assume this is where we stop me from doing something stupid, like pasting a password.
Exactly that. You can have this hook scan your prompt for patterns that look like API keys, secrets. If it finds one, it just kills the process.
That just stops.
It uses a specific mechanism. It's called exit code 2. This is a standard in this architecture. If the hook script exits with code 2, the prompt is blocked. It never goes to the AI. You just get an error back in your terminal saying, hey, you're about to paste a private key. Don't do that.
That's the front door. But what about the back door? I'm always more worried about what Claude is going to do. I've had that sinking feeling where I ask for a cleanup and I think, it's going to delete the wrong folder.
That's the nightmare scenario, and that's where the PreToolUse hook comes in. This is arguably the most important safety net in the entire system.
So how does it know the difference between a good command and a bad one?
Claude uses tools to interact with your computer. Writing files, running terminal commands. This hook fires after Claude decides what to do, but before the command actually executes. And the repository has this great example called the dangerous command blocker.
I like the sound of that.
It scans the command Claude wants to run. If it sees rm-rf sudo or, an attempt to read your env file where your secrets are, it intervenes.
The dreaded rm-rf.
We've all been scared of that one. And here's the really cool part, the technical detail. It doesn't just block it silently. It returns a JSON object back to the AI.
A feedback loop.
Exactly. It sends back something like decision, block, reason. Recursive delete is not allowed without manual override.
So it tells the AI why it stopped it.
Yes. And that is so crucial because it lets the AI self-correct. Claude sees that message and thinks, oh, okay, I can't do that. I'll try deleting the specific files instead. It turns a potential catastrophe into a learning loop for the agent.
That's the difference between a tool crashing and tool adapting. It's actual engineering.
Precisely. It keeps the agentic loop going while keeping your system safe.
Okay, so we've guarded the input, we've guarded the execution. But what about when things actually work? The source talks about feedback hooks.
Right. This is where we shift from security to utility. We have the post-tool-use hook. The tool has run, the file is written. Now what?
Usually, nothing. I just go check the code myself.
Right. But in an agentic workflow, you need a record. This hook is used to turn all those messy terminal logs into a clean, structured chat.json transcript.
Is that really necessary, though? I mean, I can just scroll up in my terminal.
You can, but other agents can't. If you want to build a system where one agent reviews the work of another, or you want to analyze your session later, you need that structured log. Chat.json provides that machine-readable history.
Ah, okay, so it's not for me, it's for the next robot in line. That makes sense.
Yeah.
But speaking of things for me, I have to ask about the notification hooks. The source mentions text-to-speech.
Yes, the notification and stop hooks. This is the fun part.
I have to admit, I rolled my eyes a little when I read voice notifications.
Yeah.
It feels a bit gimmicky. Computer status report.
It does feel a bit Tony Stark, I get it. But think about the actual workflow. Agentic coding often means you give Claude a big task, refactor this entire module, and then you wait. It might take 2 minutes, it might take 10, you tab away to read email.
And then I completely forget, and 20 minutes later I realize it's been waiting for my input the whole time.
Exactly. The notification hook integrates with 11 Labs or OpenAI to literally speak to you. Your agent needs input, or subagent task complete. It brings you back into the flow.
Does it rely on cloud APIs? Because I don't want to pay for a voice every time my code compiles.
It has a voice priority logic. It tries the high-quality 11 Labs voice first. If that's not configured, it fails over to OpenAI. If that fails, it uses the local system voice, the robotic one on your OS, so it makes sure you get the message one way or another.
Okay, I'll admit, having my computer politely clear its throat when a job is done, that does sound useful for multitasking. But I was more intrigued by the stop hook. The source said it can actually prevent the AI from stopping.
This is a critical piece of agentic engineering. Sometimes Claude thinks it's done. It wrote the code, it sees no errors in its logic, so it signals task completed. But maybe the test suite hasn't actually finished running in the background.
It's checking out at 4:55 p.m. because its desk is clean.
Basically, yeah. The stop hook can check the actual system state. If the tests are still running or if a specific output file hasn't been generated yet, it blocks the stop signal. It forces Claude to stay in the session until the real criteria are met.
That is the definition of done. You're enforcing rigorous engineering standards on a probabilistic chatbot.
And that enforcement is what lets us trust the system enough to scale it up, which brings us to the real mind-bending part of this repo, the subagents and the meta-agent.
This is the inception part. We are going down the rabbit hole.
Deep down, we move from single scripts to a whole architecture. The repo uses a folder, .claude agents. Inside, you have these definitions for specialized agents, a database expert, a front-end designer, a testing specialist.
So instead of one generic Claude, I have a whole team of specialists. But how's that different from just, asking Claude to act like a database expert?
It comes down to the prompt engineering. And the source highlights a massive misunderstanding people have here. The files in the .claude agents folder, they are not user prompts, they are system prompts.
Okay, break that down for me. Why does that distinction matter so much?
A user prompt is just part of the conversation history. It can be forgotten as the chat gets longer or diluted by other instructions. A system prompt is like the God voice. It defines the fundamental constraints, the personality of the model. It carries way more weight. And critically, in this architecture, some agents don't talk to you.
They don't talk to me.
No. You talk to the primary agent. Think of them as the project manager. The primary agent then delegates to the subagent. The subagent does its work and reports back to the primary.
So I'm the CEO. I tell the PM what I want. The PM harasses the specialist.
That's the idea, yeah. And to make it even more meta, there's the meta agent.
Agent that builds other agents.
Correct. There's a file called metaagent.md. You can tell it, I need an agent specialized in Python crypto libraries. And the meta agent will write the markdown file, define the system prompts, set up the right tools, and configure all the formatting for that new agent.
We're using the AI to build the tools that run the AI. It feels like we're getting very close to automating ourselves right out of the loop here.
That's the goal of agentic engineering. You want to build the thing that builds the thing. You stop writing the code, you start orchestrating the workforce.
And here's the problem with workforces. People and agents make mistakes. If I have a chain of agents, Agent A does research, hands it to Agent B, who writes code. If Agent A hallucinates, the whole chain is poisoned.
That's the classic compounding error problem in these agentic loops. And this repository proposes a solution for it. Team-based validation, specifically the plan team workflow.
Plan team. It sounds like a slash command in Slack or something.
It functions just like one. It introduces a builder-validator pattern. You never let a single agent do critical work alone. You assign a builder who has the power to write and edit files. And then you assign a validator.
And the validator's job is to?
They have read-only access. This is key. The validator cannot break the code because they can't touch it. Their only job is to read what the builder did and check it against the requirements. If it's not right, they reject it.
It's a dedicated QA department for your AI.
And it's orchestrated by what's called a self-validating prompt. The prompt itself has hooks that check. Did the output file get created? Does it contain the required sections? If not, the task just isn't marked as complete.
The source also mentions something about bash sleep loops being a thing of the past.
Oh, yes. In the early days of AI scripting, which was, like 6 months ago, if you wanted to wait for a file to be created, you'd write a script that said sleep 5, check, sleep 5, check. It was brittle, it was slow.
The please don't crash loop.
Exactly. This system uses a proper event-driven task system. If a task is blocked, it just waits for its dependency to resolve. It's actual software engineering patterns being applied to prompt engineering.
It feels like we're growing up, moving from hacking it together to proper architecture. But I want to pivot to the user experience, because all this logic is great. But if I'm just staring at a blank terminal, I'm going to get bored. The repo has a lot of quality of life features.
It does. And the status lines are a great example of just how fast this stuff is evolving.
I saw there were something like 9 versions of the status bar.
Yeah, version 1 was just get info. Version 5 added cost tracking in dollars.
Which is terrifyingly useful, watching the dollars and cents tick up in real time.
It keeps you honest. If you see your session has cost $4, maybe you stop and check if the agent is stuck in a loop. But version 9 is the full Powerline style interface. It's beautiful, but it also adds agent naming.
I loved this. Phoenix, Sage.
It uses a local model like Llama or Anthropic itself to generate a unique name for each session. It sounds trivial, but when you're looking through logs later, searching for session ID 54829 is a nightmare. Searching for Sage's logs is easy.
It humanizes the machine just enough to make it friendly.
Yeah.
Without, tricking you into thinking it's actually human.
That's it, exactly. And then you have the output styles. You can actually change how Claude talks to you with output style.
I saw Genuine mention that generates HTML.
Yep, for visual outputs. But for developers, ultra concise is the real winner.
What does ultra concise do?
You know how Claude can be very polite. Certainly. Here's the code you requested. I hope it finds you well.
I would be happy to help you with that. Just give me the code.
Ultra concise strips all of that. Minimal words. Just the code lock. It optimizes for speed and for token cost.
And there's always a but. If it's just throwing code at me that fast, how do I know it works?
And that brings us to the final layer of safety. The code quality validators. Rough validator and tie validator.
I'm assuming rough is the linter.
Yes, a very, very fast Python linter.
Yeah.
And tire80 is for type checking. These hooks run after Claude writes the code, but before the task's marked as done.
So if Claude writes valid logic, but forgets a semicolon or uses a variable that doesn't exist,
The hook catches it. It feeds the error right back to Claude. Claude fixes its own linting error. Then you get the code.
it's like having a senior developer reviewing every pull request instantly. The AI literally cannot finish the task until it passes the linter.
That is the definition of moving from vibes to engineering. We are enforcing standards programmatically.
So let's just zoom out. We've gone through a lot here. We have hooks that block dangerous commands. We have context injection so we don't repeat ourselves. We have meta agents building sub-agents, validators checking builders.
It's a comprehensive ecosystem, really.
And it really feels like it represents a shift in responsibility. In the vibes era, the human provided the intent and then checked the work. In this agentic era, the human provides the architecture. We build the system that checks the work.
Tactical agentic coding, that's the phrase. The AI provides the labor. But the quality of that labor is enforced by the code you wrote in these hooks. You aren't just a prompter anymore. You're the architect of a synthetic workforce.
That is a powerful takeaway. But here's a thought to leave you with. If we have a meta agent that can write the system prompts for new agents, and we have validator agents that can check the code written by builder agents, and we have hooks that automatically fix linting errors,
I see where you're going with this.
how far are we from the point where the human's only role is to type start? If the system can build itself, check itself, and fix itself, are we the architects or are we just the ignition switch?
That is the ultimate question. And looking at a repo like this, the distance to that future is getting shorter every single day.
Something to mull over while you're configuring your armed RF blockers. Thanks for listening to The Deep Dive. We'll see you next time.